On this episode of For Fun Flyer, the installation of the old and designing and test cutting of new cockpit panels, doing some investigation and changing the wingtip lights to LEDs. Hi guys, welcome back to another episode of For Fun Flyer. This episode is not about flying, but about doing some maintenance work and some renewal work on my new airplane. As you might have noticed already, I bought a new used airplane, a TL96 Star from TL Ultralight. And it's nothing too dramatic, the stuff that I have to do on the plane, but still there are quite a lot of little things I want to change and improve before I start using the airplane a lot more. So join me on this little technical trip, and I hope you enjoy it, so stay tuned. So I'm inside the cockpit of the TL96 and I'll show you around and give you an impression of the state the airplane is in right now as I bought it from the previous owner. So it's dual stick configuration, no yoke, just two sticks with analog instruments on one side. The other side is still unused, but I've got plans for that, of course. And an instrument for the engine readout and radio, circuit breakers and switches. That's basically it. So here's the instrument layout as I bought the airplane. It consists of a couple of instruments, but basically the basic instruments needed for flight. So the airspeed indicator, of course, vertical speed and altitude. And you've got here a little manifold pressure gauge, but since this airplane has a fixed pitch propeller, it's no use. So I don't think I'll use it, but perhaps if I've got space in a new dashboard, then it's okay to reuse. And here you have the mid section of the cockpit panel that consists of the engine monitor instrument, the flydet. It's pretty common in microlight, ultralight aircraft. It performs really well, and you got a load of information on it. So I'll keep that and use that for the future. Brand new radio, 8.33 kilohertz spacing, and you got here the circuit breakers and the switches, but there are a lot of switches inoperable right now, so I'll just figure out the wiring and redo this section again. Actually the whole panels, all the three panels, I'll make brand new, so it's way easier to redo it than to reuse the stuff inside of it right now. And over here you have the mid section, the lower section of the middle console with of course the throttle, the elevator trim, the prop adjustment, the prop pitch adjustment switch. But since it's the original variable prop is replaced by a fixed pitch propeller, it's no use anymore. So I'll have to figure out what I'll do with this spot inside the midsection. And you've got the choke and the heater, the control for the heating. Well, that's basically it. So. So I removed the seating and the back seat. I always wondered where the high voltage part of the strobe and navigation lights were tucked away in this plane. But now I know. So I'll replace my lights with LED. So this all can go. And what I'm actually looking for is a way to get inside to the headset connectors, because I purchased two A20 Bose headsets and they don't work, but that all has to do with how the headset connector in the chassis is connected. So I uninstalled the headset connectors from the chassis of the plane, and it's just as I suspected. They wired via a little wire bridge the let me show you on the connector, the ring with the tip of the connector So this is called the sleeve, this is called the ring, and this is called the tip. And with a stereo headphone jack, that doesn't matter, right? So if you connect it to either that one or that one, if it's a mono headset, it will work. But I got a connector, just the standard GA mono connector. And when this is connected with this, with a mono connector, the ring isn't there. So it's connected to the ground. So if you hook that up inside your airplane, you just basically short circuit the output of your transceiver via the mono plug. So this is exactly the root cause of the problems I had with my Bose A20 headset that just utilizes a mono GA connector. So this is basically not the most ideal way to connect a headset connector. So you just want to use the tip and otherwise make another adapter connector, but this should be separate from that and that. And with this connector soldered like this, it's just one short circuit. So if you use a mono connector, it won't work. And basically it's hazardous for your transceiver because you can blow stuff up. So if it doesn't work, guys, check this out. And if you have any questions in detail, just write me a comment in the comment section of this video. So I think I'll just order a couple of new connectors for the chassis and wire it up properly so my Bose A20 works. So, little status update. What I did is I unscrewed the panels. I don't know if the video is showing, but I unscrewed the panels from the cockpit and I traced them on a piece of paper in order to get the exact shape scanned into the computer and vectorize it so I can trace it in a CSV router. So this is the piece and these are the traces. So now I have a nice flat drawing of the shape of the cockpit panel. So the next step is to scan it into a computer. So to vectorize it, the whole setup of the new panel will be different, but I have at least the shapes that worked in the previous original setup. So let's do the rest of them and see how that evolves. So another day and another step in the process of making some new cockpit panels. So the couple of first steps you witnessed inside the hangar. I traced the old panels onto a piece of paper. I've scanned them, those drawings on my business copier and scanner. And after that, I'll walk you through a couple of steps of the complete process. So the first thing I did after I scanned the shapes of the cockpit panels, after I traced them onto a piece of paper, was check the scale of the scans. So I drew a line in the real life scenario with a certain measurement to it, to check if on both the X and the Y axis the scan was exactly to scale. So that is corrected in this PDF. After that I traced the PDF into a vector type of drawing, and as you can see here I did some GUI designing of all the buttons and instruments where they should be put on the new panels, etc, etc. So well, I was pretty satisfied about this setup. Here we'll have the speed indicator, the Garmin G5 EFIS, altimeter, vertical speed indicator, an info device. I'll tell you more about that instrument later on. And here we've got a slip indicator. So it's not your completely standard six-pack, but pretty close to it. And the next step after that is to just leave the trace, which is ready to be cut out of carbon sheet. But I'll first make a couple of test pieces on some cardboard so I can physically test the shape and geometry in the airplane. So that's up next. If you're wondering exactly where I'm going to cut out the test shapes of the cockpit panels, At which company that will be? Well, that will be my own company. I'm a small business owner and I'm an engineer of all sorts, so I do software engineering, electronics engineering, prototyping, product design, etc, etc. So I've got a couple of sophisticated machines where I can do some prototyping onto, and one of those machines is actually a laser cutter. Well, let me just show you. It's way better. So welcome to my little maker space, and here's the machine I just spoke about. It's a 60 watt CO2 laser cutter, and it allows me to cut on most materials up to about a half an inch of acrylic. Watch this. Pretty awesome, huh? This never gets old. Seeing something getting cut out of some sort of material via laser cutter is just always fun. So when the smoke clears from the laser cutter, I can access the part I just cut out, and as you can see, it's just really thin paper, or thick paper and thin cardboard, and there you have it. The shape I just drew in the computer, and this will be the exact shape and dimension of the definitive cockpit panel. So that's pretty awesome. Since I switched on the laser cutter, I decided to cut out the adapter plates for my wingtip, my LED wingtips too. So the wingtip lights that are on my airplane right now are from Whelen, if I pronounce it correctly, and I'll replace those for some LED lights of Avio Lights. It's a small Polish company that produces outstanding wingtip and other aircraft lights in LED, and with a huge variety of lights. And so I have to make an adapter plate to fit on the holes and the space on my wingtip as the lights I have right now. And they have to be able to house the new lights on them. So I'll show you in a couple of seconds what the shape looks like. So here you have it, the shape of the adapter plate. So we've got the red outline is the outline of the adapter plate. The blue line right here is the shape of the new LED lights, and these are some mounting holes and wire holes for the LED lights. So basically this light will attach to this plate, and that will attach to the whole wingtip and cover the complete surface of the original lights that are on my airplane right now. So, and it will be a sandwich of two layers. So this is the top layer, this is the bottom layer holding the nut, the mounting nut for the new LED lights. So I'll make two of those and one separate of those, because my company logo has to be readable, right? So that's why I split the designs of those two. So, well, let's throw it onto the laser cutter and see what comes out. So for the adapter plates for my LED lights, I use acrylic, as I said before, because I can laser cut it myself. And I've got this acrylic, I don't know if the camera is showing right now, but it's reflective. It's a silverish kind of plastic, which allows a better reflection of the light that will be emitted by the LED lights on the wingtips. So I think it's a perfect candidate for this application. I think I might can squeeze out two complete sets. So let's see how that works out. So. So the laser cutting is finished. I've got some parts laying on my desk right now, so the paper cutouts as I showed you on a video previously, and I made the adapter plates for my lights, my LED lights. So as I showed you on the drawing, this is the part where the new LED lights will be screwed on. and this complete sandwich is glued together. So let me show you right here. It's a sandwich of 2 layers of acrylic, and that's because the new LED light is connected via this hole in the middle right here. And if I show you the back side of it, you'll see the cutout shape of actually hexagonal shape for the nut. So the nut will be glued here in as well. So once this place is installed on the wingtip, you can just screw and unscrew the LED lights with a nice M5 metric 5mm bolt. So that's basically how this is developed. So all I have to do right now is to glue those parts together, and I've got a complete adapter plate for the current Whelen 2 Avio lights, LED lights, wingtip lights. So what do you think of my brand new LED wingtip lights? Curious how I did this? Check this video. While I'm wrapping up the work on the new wingtip lights in the video, I'm wrapping up this episode in post-edit. Thanks again for watching. If you like this episode, please hit the thumbs up button, as well as the subscribe and the notification button. That's the little button with the alarm bell icon on it. Any questions or comments on this episode? Share them in the comment section of this video. I would love to hear your thoughts on this one. Don't miss out on the next episodes. Check out the website for frontflyer.com for more info, and of course the monthly contest. And as always, I hope to see you next time. Fly safe. Bye.